Okay, I'm going to be solving the USACO 2017 December Contest Silver, Problem 2, Milk Measurement. So, the first thing we notice is that there is no possible way to solve this problem by storing all the cow milk outputs in an array and then checking for the maximum milk output every time a milk measurement changes. If we did this, the time complexity would be 10 to the power of 9, which is the number of cows, times 100,000, which is the number of milk measurements, or the lines of input. And in the worst case, this would be way over the time limit. So what we need is a way of storing the amount of milk output a cow has and being able to change it really fast. As you can see, the milk output of a cow is always changing, and it may need to change more than once. For example, if the first event is on day 1, cow 1 increases its milk measurement by 2, but on day 2, cow 1 decreases its milk measurement by 2. One cow would have to go through a lot of changes, and we would need to do this multiple times. So we will need a data type that finds a cow ID and its associated milk output fast, and also has the ability to change the milk output, like multiple times. And a hash map would do all these things, like using the dot put and the dot get methods. But we still have the problem of checking what the maximum milk measurement is and the amount of cows on the board, since Farmer John must change the board every time the milk measurement or the amount of cows with the maximum milk measurement changes. The easiest way to do this is to go through the input data in real time or by sorting the input data by day number. By doing so, we can check the amount of milk output a cow has after its measurement changes and compare it to the maximum amount of milk on the board or the maximum number of cows on the board that have that maximum amount of milk. But we still have the problem that we have to check the amount of cows who output each amount of milk, because right now we're not checking that. We do this because if the number of cows with the maximum output changes, then Farmer John still must change the board display by adding or taking away a, um, a cow on the board. For example, at the start, all the cows output 10 milk. However, as cow 1 increases their milk output by 2, as on the last line, the amount of cows with 10 milk decreases to 3 from 4, and the number of cows which output 10 plus 2, which equals 12 milk, increases to 1, since cow 1 is now outputting 12 milk. So we will need another data structure which counts how many cows are associated with each amount of milk output. Since we eventually need to find the maximum milk output within this data structure, we can probably use a tree map since it sorts its data by keys. So basically, we need a tree map to count how many cows have a certain milk output, a hash map to keep track of the cows and their most recent milk output, integers n, which is the number of measurements, and g, which is the starting amount of milk output for each cow, a class using comparable to sort the input, and integers board count and board milk to keep track of data on the board, where the board count is the amount of cows on the board and the board milk is the milk output for the cows on the board. So let me write this down for a second. So we need a tree map to count how many cows have a certain milk output, and we need a hash map. This will keep track of the cows and their milk output. And we also need the integers n and g. N is the number of measurements or lines of input, and g is going to be the starting amount of milk output for each cow, so the initial amount. And we're going to need a class implements comparable. Sort the input by day in an ascending order. And we're going to need a board count, so the amount of cows on the board. And we're going to need a board milk, which is the milk output for the cows on the board, or the maximum amount of milk output. Okay. So we can start coding. First, we import java.util and import java.io. We're gonna probably need a buffered reader since there are gonna be a lot of lines of input. Static buffered reader and static string tokenizer st. Static print writer out. And we're going to need to create the class. Let's do that first. So static class, let's call it triple, implements comparable. Now we're going to need to add an unimplementable data type. And then, so first we need the integers. So we need the date, the ID, and the milk output stored in it. So we need the int date, and then the ID, and then the milk changes. So plus or minus some random number. And then we're going to do triple, int A, int B, int C, date equals A, int equals B, milk equals C. Okay, and in order to print it, we need to do public string to string A plus. Okay, and in this section, we're going to have to sort the input by day. So we're gonna have to use this dot date, and we're gonna have to do it in ascending order. So this dot date minus o dot date. But we still haven't actually created the data. So we're going to have to create something called status triple A, like an array. And then we're going to need to add an exception. Okay. So first we'll need to initialize it. Solve, then in.close, out.close. Okay, so let's get to the initializing part. So static void init, and we have to do throws IO exception. So first we have to get the integers n and g. So st equals new string tokenizer in dot read line. And we'll also have to have integers n and g, so static int n g for now. And n equals integer dot parse int st dot next. And same thing for g. And then we'll have to get all the input inside the triple class a. So a equals new triple. T equals new string tokenizer. Read line. AFI equals new triple. Integer parse int. That was a couple of times. And then, of course, we have to store a. And then remember that we have to create a a tree map. So we can call this milk. So add it up here. Static tree map. Integer. And we also need a hash map. And we'll name this cows since it contains data on the cows. So milk equals new tree map integer. Remember that milk is a tree map showing how many cows have a certain milk output. So in the very first scenario, before we have read any of the lines, all of the cows are going to have a G amount of milk output since it's like the initial amount. So we're going to have to put milk output G and 1 billion or 10 to the power of 9. What this basically means is that there are 10 to the power of 9 cows, and all of them are outputting G amount of milk. Now, it doesn't, you might be wondering why we're using 10 to the power of 9, and it's because we don't really know how many cows there are yet, and since 10 to the power of 9 is the maximum amount of cows, we're just going to set it to that for now. And then we have to do cow equals new hash map integer cows. And we also have to have the integers of board count, which is the amount of cows on the board. So we'll add that in, board count. And we also need board milk, which is the maximum milk output for the cows on the board. So board cow, let's set it equal to 10 to the power of 9. And board milk will equals G, because that's the milk output at the initial milk output at that time, and max is also G. where we need max because it's the maximum amount. And it's the maximum amount of milk that a cow outputs. So now we'll need to do the solve part. Static void solve. So since the class A is already sorted, we're just going to have to go through each of the values inside it since it's sorted by the day. So for triple T in A, okay. So we set the current ID as ID. So int current ID equals t.id. And then if it's a new cow that's introduced, then you have to add it to the cow data, right? So if the cow contains key. So if it's not in the data currently, then we'll have to add it. Cows. Cows is going to be like keeping track of the cows and their most recent milk output. It's going to be cows.put per ID and G, since that's their default output value. And then we're going to make the current milk output of them cur milk equals cow.get ID. Since since it's possible for that cow to have already been in the array, we have to make sure that it's a separate variable. And then since the data will change, we must subtract 1 from the total amount of cows who output that amount of milk. So in the data milk, in the tree map milk, which is going to count how many cows have a certain milk output, when the data changes, we have to subtract 1 from the amount of cows who output that amount of milk. So right now there are like 10 to the power of 9 cows who output G amount of milk, but we have to subtract 1 from them because one cow in among those 10 to the power of 9 changed. So milk.put per milk, which is just going to replace it, and that milk.get per milk, and then you subtract 1, since one cow, the current cow, changed. And if there are no more cows with that amount of milk, say there was one cow that outputted 2 milk, but now it increased by 1, so there are no cows that output 2 milk, we can just remove it since no cows have it, and it's no longer important. So if milk.get cur milk equals 0, then milk.remove cur milk. And if the cow is already on the board, then the amount of board on the milk must change too. So if cur milk equals max, so the milk on the board, then you have to add it to the board milk. So board milk plus equals g dot milk. And we're also, if the current milk changes, the current milk will also have to change since it's being changed in that line. So cur milk plus equals g dot milk. And then we can change the data inside cows and change the amount of milk the cow has since it's a hash map. There cannot be multiple keys and it will replace the value before. So if we do cow.put current ID and current milk, It will replace the inform it'll replace the data before, and then it's going to update the amount of milk output a cow has. Now, let's say there was already cows who have that amount of milk output. Then you would add 1 to the amount of cows who have the same amount of milk output in the tree map milk, because then you would be increasing the amount of cows who have that amount of milk output. So if milk dot contains t cur milk, if there are other cows who output that amount of milk, then milk dot put cur milk, milk dot get cur milk. This is basically just doing plus equals 1, but since we can't do that in a tree map, we have to do it this way. And if there isn't, you have to create a new data or section where there is only one cow and the current one who outputs cur milk instead of cur milk amount of milk. So it has to be a new unique cow. So else milk dot put cur milk. And since there's only going to be one cow and it's the new one, it has to be 1. And then now, since everything is set up, we have to get the maximum amount that any of the cows output. And since we use the tree map, which automatically sorts everything, we can just do max equals milk dot last key. This is going to be the greatest value, and it's sorted in ascending order. And max count equals milk dot get. Change max. And now we have to check if the maximum amount of milk changes or the amount of cows that output the milk changes. So if max is different from the amount of milk on the board, so board milk, or max count, so the number of cows who have that maximum amount of milk, not equals the board count, then we'll have to do need to create a variable called answer, keep track of how many times Farmer John changes the board. So we'll have to do ans plus plus, since Farmer John must change the board. And then board milk equals max, updating the board. And board count equals max count. And then in the end, we're going to have to do out.println. And we should probably be able to submit it now. So here, Java, milk measurement silver, submit. And yeah, so that was the problem milk measurement. I hope this helped.